Good evening.
Good evening.
Pleasure to meet you guys. My name's John Buchanan. I'm a Biosystems Engineering and Soil Science Department, so I'm an engineer with the University of Tennessee. And as Faith indicated, treatment is an option. I think treatment's a great option, okay? Now, don't ask me what the rules are about the food safety stuff. Ask me how to kill bacteria. I got you covered, okay? So I might inadvertently say, well, just go get you a bag of chlorine from a swimming pool place. But no, you can't do that. You got to get the chlorine from a supplier who has that product labeled for irrigation use. So that's always an important point that I have to remember to say, okay? Otherwise it's just chlorine. But we'll cross that bridge as we get there. Okay, now, treatment. We can toast those little buggers several different ways. We can fry them with some chlorine. We've been doing that for 200 years nearly now, okay? So we know chlorine works. We did research on the Plateau Experiment Station, Research and Education Center, where we took water you would never use for irrigation. Absolutely never use for irrigation. Cattle had access to it. Cattle were in the water, okay? We took that water and sterilized it, okay? Now it still smelled like you know what, but it didn't have any bacteria in it anymore, okay? So we know we're not going to use water anywhere near that contaminated, okay? At least we hope we're not going to, okay? So we know that we can take this 126. We know we can take 200. We know we can take 2,000 of the colony forming units per 100 milliliters, the units you heard earlier, okay? And we can bring that down below that number. I mean, we can make it 0 if you want. Just a matter how much chlorine or other oxidants that we want to add that we're going to add to it, okay? So treatment is something we're familiar with, okay? The water, if you're from here in the Ashland City area or Cheatham County area, you're getting your water from Sycamore Creek. You're getting your water from the Cumberland River. We know how to treat that water, okay? But the issue is making it affordable, okay? So do it in such a way that it doesn't add a tremendous amount of overhead to your farming operation. So what I want to show you is really simple, okay? And we want to keep it simple. And when we did this program before, 2 weeks ago, the folks that came and listened to us said, wow, that's all we got to do? Yeah, okay. It's really not as bad to provide the treatment that you might think. So I want you to look at this right here, and this pipe right here is coming from your pump, okay? So it's got your quick disconnects on here. This is coming from your pump, and so this is your water flowing through here. So let's say that we need to mitigate. We need to bring the bacteria count down, and we may have chosen to use chlorine, okay? And so because of freezing temperatures, the jug is empty right now. But we need to get the chlorine in the water, and we need to provide it some amount of time for the chlorine to react. So a setup like this, a simple setup where you have your pump coming in, plugged into this, and all this is doing is providing a location for you to inject the chlorine into the flow. That's all this is doing. And then this goes back out, and then this pipe's going out to your field, okay? To your drip, to your spray irrigation, to whatever style of irrigation you have. All right, so with that, we've got to look at how to get the concentrate from here into the line. And what I'm demonstrating is 2 different styles of injection pump. This is referred to as a diaphragm pump. The other one's referred to as a peristaltic. Sound like pretty fancy names.
This one's what now?
Called a peristaltic. Okay, and let's turn it on. All right, let's see. There we go. So you can see it's a tubing pump. You can see the rotors going around, and this would draw up out of there and put it into the line, okay? If you've had the misfortune of needing to be in the hospital lately, that's an IV pump, just a little bigger, okay? So it's the same technology that we use on medical conditions. This is a diaphragm, and I don't leave it plugged in because it's a little more noisy. Right one, yep. And so this is like a heart. It squeezes in and out. It's got check valves on top and bottom, and with every pump you can see it's pumping up, pulling out, and pushing up through there. The advantage of both of these pumps is, you know, your irrigation line maybe is 60, 70 psi. That's a lot of pressure. And so this puts enough pressure on there that it can force that into the line. Okay, that's an important component, but yet we can control how much fluid is being pulled out of your concentrate. So one of the things we've got to think about, okay, yep, so turn that down. We've got to think about what the flow rate's going to be, your mass flow, compared to how much concentrate you want to add, okay? So we won't pretend to be able to do that tonight, but we need to have an understanding of what our flow rate is, okay? So we'll know how many pounds of water, not just gallons, but pounds of water, so we can mix this with so many pounds of concentrate to get a ratio. Okay, if that sounded pretty rough, think about fertigation, something else that you do, okay? So in thinking about getting that nutrient out there to a crop, you already know how to do that math, so this math is not terribly different. So I think you'll find that pretty easy to handle. Okay, so what you see is a rack that we can mount close to our water source. So again, this would be coming from your pump. You might have this, you know, close to your main pump or something where you might already have electricity, or if you're running off a diesel pump, you could use a gen pack. Okay, so that's purely 120 volt. You could also get these 12 volt DC if you want to run it off a solar panel. So both of these could go either way. Okay, this is going to be less expensive.
What kind of expense are you talking about?
Okay, great question. That right there is $180, but you don't have to have one that good, okay? Because I do run a lab at UT also, these are lab quality, okay? We don't have to have lab quality. We can go to Granger's, we can go to, I was gonna say Harbor Freight, but nah, let's not go to Harbor Freight. Okay, nah, let's not do that. But there's plenty of industrial supply places that carry that style of pump. The peristaltic is a little higher end and probably not necessary for what we want to do on farm. The reason that I want to demonstrate it though is, you see it sucking those bubbles up. One of the chemistries we want to talk about is called peroxyacetic acid or peracetic acid. It goes by both names. And it has a strong, well, if your parents raised you right, whenever you scraped your knees, they put a little hydrogen peroxide on you, okay? If you were raised right. Now, imagine that hydrogen peroxide multiplied many, many, many times, and then add a few other oxidizers in there, mainly the peracetic acid. A very good disinfectant, but it produces an off gas. Remember when the hydrogen peroxide got put on your scab, on your wound, it gassed up? Well, it will gas up, and so I'm thinking, from my experience anyway, that peristaltic pump can handle those gases a little better. Whereas this one might vapor lock if you're using the peroxyacetic acid, okay? So, you know, it's really two different thought processes there. That one that you see there on the peristaltic end, that's a $300 pump, but again, we could probably get that down to $200, all right, with a little lesser grade. All this other plumbing that you see here is really so we can demonstrate water actually flowing through here. I didn't think with the lights and stuff that we had to have this afternoon it would be very effective. The last time I did this, I had blue and green food coloring in there. And I found out the hard way that blue and green food coloring will stain your clothes. I didn't know that, okay? But it will stain your clothes. So I opted not to do that just tonight. Plus, as many of you mentioned, it is going to freeze. So
the clear is nothing more than a visual aid.
It's nothing more than a visual aid.
Okay.
Yeah, that's exactly right. You know, if I had a concentrate of chlorine here or a concentrate of the parasitic acid, this would still be clear, okay? And this would be slightly yellow, okay? So, and that's about all you'd really see. So one style, chemical injection, okay? So we've got a disinfectant that would be here, okay? We would need to know what its concentration is. We would need to know what our flow rate is, and we would adjust this so that we ended up with maybe 2 part per million, 4 part per million, okay, left over. And Faith has these cute little strips, okay, that she can dip into that water and say, hey, wow, we've got 10 or 15 part per million residual chlorine, okay, or 2 or whatever works, okay. So the fewer bacteria you have in water, the less chlorine that you need to provide. Now let me flip that though, okay. What if this is your pump right here, this is your injection system, and your crop is right there, okay? That's kind of problematic because then you don't have really enough time for water to flow through all this and provide contact time with the chlorine and the microorganisms, okay? When Ashland City or Pleasant View or whatever little community you have that's producing water, their standard is 20 minutes of contact time. We don't have that luxury, okay? We've got seconds from the time the water goes through here and gets out to your field. We overcome that by increasing the dosage of the chlorine or the parasitic acid, okay? So when you don't have time, you add a little more of the disinfectant to do the same job.
Is that the full time of irrigation, or is that up to a certain time?
That's from the time that the water receives a little bit of chlorine until it comes out the emitter to your crop, okay? And so when you have the pipe and you pump and everything, the water moves through that pretty fast. Yeah.
You start the chlorination or the pump prior to starting your irrigation pump and then run it after that?
Absolutely. So let me paraphrase your question again, okay? So I want to start injecting before I turn my main pump on because I have to treat every drop, okay? I have to treat every drop. The good thing about the chemical injection is I do have full system treatment, okay? I'm putting the chlorine in here. I'm going to have residual all the way through the distribution system. So I'm going to get chlorine all the way out there. Okay, now that's my segue to get you to scoot down here a little bit and look at the next technology that does not have the residual in the distribution system as you go out in the field. And this is the ultraviolet light, okay? Now, I think we're all familiar with UV light. One of the, some of the really cool third world country water treatment that we talk about is taking these plastic water bottles and putting them up on their roof of the third world folks' house to get UV light to disinfect their water, okay? And they go, wow, that's neat. And, once upon a time before disposable diapers, we washed the diapers, we hung them out on the line, and that cloth got sterilized, although we didn't realize it, by the ultraviolet light, okay? Well, this is that same technology. And so this is your irrigation line. This is where your pump would connect. This is where your hose would connect. And so I've got this closed to force it to split, to go across 2 reactors. And you might notice that when I take that off right there, you can see the purple glow. Now that's as close as I can let any of us get to it because if you look directly at the tubing that's in there, it would damage our eyes. Okay, this is the real McCoy ultraviolet light. This is producing its main wavelength at about 254 nanometers. Okay, now that's a nice number. It's a nice number. The number that we really want to recognize though is at about 260 is when you get the best kill of UV light to microorganisms. So these two lamps that are in there, by wonderful coincidence, happens to be at the right wavelength to get a real good germicidal kill. Okay, so
Wait,
yes,
you said those are what wavelength?
254,
And you said what's the optimum?
about 260. It's real close.
Okay, okay, that's what you say. Got
Yeah, it's real close. And it's by coincidence more than anything that, oh, by the way, this particular light works really, really good. Now,
So the two of them together is not going to give you 260. It's just getting close.
that's right.
Okay.
That's right. And that's right. So the reason I've got two of them here is because these are not inexpensive, okay? These are not inexpensive. So this right here was, I think each one of these was 750 bucks, okay? And these are not listed or not advertised for irrigation water. But we're not worried about that because what did you call them, Faith? Devices?
Oh, they're EPA registered pesticide devices.
Pesticide devices, okay? I'm happy about that because the people who sell you these things are really selling these to folks who want to treat their own home water more, okay? You have
What's
folks
the
with
lifespan of those bulbs?
1 year, 1 year.
What's the replacement cost?
$100. Okay? Now it may last more than that because the 1 year that I quoted you at is with that bulb being on 24/7. Okay? That's not going to be our case. However, these bulbs will still fade.
They what?
They'll still fade.
Okay.
Okay? And that's ultimately what we're concerned about.
Right.
What a great segue question once again.
You
Okay.
still have the time frame in the ultraviolet light.
Right.
The time span.
That's right. So we're counting, the design, that's actually how we choose these. We choose these based on how long it takes water to get from the entrance to the exit, okay? And so we want a certain amount of seconds that it takes that water to go through here. And as I showed you a moment ago, what's actually happening is you've got a fluorescent tube in the middle. You have this glass quartz around it, okay? So this glass quartz is actually protecting the fluorescent tube. The water flows around this. So you've got this small diameter tube, the water's flowing around, and it kind of swirls in there a little bit and comes out here. With ultraviolet light, you don't get an immediate kill. What you get is their inability to reproduce. So it messes up their DNA, all right? So you start messing with their genetic material, they go to reproduce again and it doesn't work. So you've eliminated them. So you won't get a kill here, you get a kill 15 or 20 minutes, okay, by the next time they try to reproduce. And you know, that's good enough for us, okay?
So it doesn't kill the bacteria initially, it just limits their ability to reproduce.
That's correct. And so if they can't reproduce, you know, especially with the heterotrophic that we're dealing with, they're going to be gone in 30, 40 minutes, right?
Right. So they don't like make babies
Right.
necessarily. They actively divide.
Right.
So and they can't divide basically, and then they just die.
Yep. They just
The
fade
other
away.
two actually kill the bacteria.
Oh, it kills them. I mean, that, I didn't really want to give you the notion it wasn't killing them. If they can't divide, they won't survive.
Right.
Okay, that's right. So, based on your question though about the longevity of the bulb, we're going to recommend, okay, and recommend may not be strong enough word. Using these devices, you really need to be able to demonstrate, hey, they really do work. Hey, we are monitoring it. And this particular one especially comes with a monitor that says, hey, we're getting 84% of the radiance that this bulb should be producing. So we've got an active sensor right here that's actually looking at that light all the time. And if that light goes off, okay, if it can't read that anymore, it'll send you an alarm. See what that does. There we go. It says, hey, okay, we're not working. Sends you out an alarm, let you know that you need to replace. An interesting thing about these designs, okay, EPA recognizes ultraviolet light as a disinfectant, okay? There's no doubt about that. And so they want to look at that size tubing, that 3-inch diameter tubing, okay, and say, with that length and with the radiance that that bulb can put out, this tube ought to be good for 7 gallons per minute, okay? Now, for drinking water, we have a 0 tolerance for E. coli, 0, okay? And so 7 gallons per minute, 0 tolerance for E. coli, well shucks, if I'm allowed 125, I can probably boost this up to 15, okay? It depends, it depends again on the quantity of the water, the quality of water you're dealing with. But I think it's going to be pretty safe to say we can go above the drinking water standard that these are sized on, okay? All right, so we've got to be careful about doing that. We still got to do the testing. Are we ending up with less than the 126 that our standard is? So again, you see 2 of them. I made the mistake. So it's really, it'd be an easy mistake to make. I thought I was getting 2 of the same ones. This is the one I wanted. All this is doing is telling me how many days I got left before I have to replace the bulb, okay? And I'm going, I got the wrong one, okay?
You got a variety.
I got a variety. You also notice I'm keeping my hand up here. It's warm, okay? It's part of they do put out some heat, so I would be a little bit nervous about doing a demonstration like this in the hottest part of the summer. I might overheat the system, okay? Right now it's just fine.
Well, those meter devices, can you also get those as direct current,
We,
like run on a solar?
yes. I had to hesitate there for a second, but there's no reason why you couldn't, because the current that drives these is not very high, okay? So I think it's safe on my part to say, yeah, I think we can get these on a solar system, a 12-volt system.
AC lights?
These are well, I mean,
You use inverter if you're going to use DC, right?
they're fluorescent, so they're already using inverter, okay? Because they don't depend on AC. Good question. I'll check on that, but I have every reason to believe that you can. Okay. Okay. So again, I've shown you 2 of them, 2 different styles, but I'm also showing you 2 of them because we can get a higher flow rate. So I've got a 2-inch line here. This may be capable of 60, 70 gallon per minute for my irrigation system. If I bought just one of these that can handle 60, 70, 80 gallons a minute, it's a lot more expensive than buying 2 smaller ones that I can put in parallel. So I can split that flow across 2 of them and be less expensive, okay? Also, with 2 of them going, if I need to do maintenance on one of these, I can shut some valves off like that, isolate this one, do the work on it, put it back on, open up the valves, and keep on going, okay? And so again, this is where you would connect your hose to go out to your crop field, okay? The beauty of this is plug and play. Plug it up, connected electricity, you've got a treatment system. The negative thing is your treatment system's just right there. So whatever doesn't get zapped, okay, right here goes on out your irrigation system, okay? I don't know how big of a negative that is. All right, lay flat. We found that lay flat is a great incubator for microorganisms, okay? It's laying out there, it's moist, it's warm, little bacteria saying it's time to reproduce. So this won't do much for that, okay? But this doesn't have a chemical cost either, okay? This is not changing the pH of your soil. This is not adding chlorides to your soil, you're getting treatment. Okay, so it's a plus or minus. I might be tempted, since I'm spending your money, I'm not spending mine, I'm spending your money, to have both. Okay, to have a way that I can put a slug of disinfectant all the way through the system, turn that off, and then depend on this for the bulk of the irrigation, and then turn that back on at the end of irrigation to clean the system out from one end to the other. Okay.
Especially since no chemicals are currently labeled from a food safety perspective for treating water. Now that could be changing.
Right.
We're expecting some of the companies to take advantage of this caveat, but this is approved without a label because it's a device.
Indeed. Indeed. Okay. One more, and we'll go back where it's warm. For larger flows, this is referred to as a tablet feeder. Okay. And so what we have is a device that we can put these 3-inch diameter chlorine tablets in. Okay, so you put these tablets down in there, put stacks of them in there. You hook your irrigation system up, okay, it would be here, and it pressurizes and the water comes up and squirts out these holes, which is in the bottom of this, okay, because this was sitting up here, okay. So this sprays that bottom layer of chlorine tablets. The bottom layer, they dissolve into the water, that falls down into here, okay, and then there's a way for it to come out the back, and that goes on out to your farm field. The way this would normally be installed is your pump pulling out of your surface water source would actually come out, pressurize this a little bit, and then where it discharges out of here would actually be drawn as part of the suction of the pump. Okay, so you'd bleed a little bit off to it and have a little bit of a circular deal, and then would force it on out in the field. Okay, these are great for larger flows. So if you've got the 800 gallons a minute, 1,000 gallons a minute flows, then this is probably the way you want to go. This is, this whole beast right here, I think it's $2,500. Okay, and so.
What monitors your chlorine fields as far as usage?
Indeed, what a great question. So that to me is the negative of this. Okay, you adjust your chlorine load by adjusting how much water's coming in here. Okay, and so then you've got to go to the other end of your irrigation system with your tab, your chlorine stick or meter, and find out how much residual chlorine you have, and you can make adjustments. Okay, you and I sing the same song. When I was introduced to this technology, I thought, gosh, I mean, I've got a lot more control with that over there. Okay, but this works pretty good. I was pretty impressed with how well this technology can work. But it is, it's really designated for the larger flows. So, we've got folks with center pivots, big irrigation systems over fresh fruits and vegetables. Well, most of them are going straight to the canneries and such, but there are some bigger irrigation systems out there.
The only other question to me is what signals you then when your pellets are gone?
It's up to you to.
So you got to monitor.
You got to monitor, okay? And so it's up to you probably on a daily basis to look down in this. It's clear on top to see how you're doing on your chlorine supply.
If you weren't careful,
you could run out. Absolutely. Absolutely. And the size that you're seeing here, this is a larger unit. We got a very nice donation from these folks. There are smaller ones of these, okay, that work basically on the same premise. But it's up to you to make sure you've got tablets going in these. My warning to you is if you're thinking about going with this technology, again, as Dr. Chrysler said, we've got to use the product that's labeled for what we're doing, and it's treating irrigation water. these folks have that label, okay? And, you know, they work with this. What we do not want to use are these 3-inch swimming pool tablets, okay? It's a little different chemistry. Okay? It's got different stabilizers in it. It's got UV stabilizers that what's been rated for this does not have, okay? I know it's cold, but gosh, you're asking all the right questions. You got more questions.
What about employee safety?
What a tremendous question. Okay, employee safety. You know, one of the things we looked at was that chlorine dioxide. Very powerful, okay? Very good disinfectant. And the first negative we found was one of the precursors for chlorine dioxide is the sodium base. So we put sodium out in the soil. We didn't really realize we were doing that. And we toasted that crop, okay? That was a lesson learned. But chlorine dioxide from a employee safety standpoint frightened me, okay? The best source of chlorine is chlorine gas, okay? That's what your water treatment folks are going to use. They can get a truckload of chlorine gas. No, not us. All right, we don't, from an employee standpoint, we don't want to use chlorine gas. Not when we get it so easily in granular forms. This peroxacetic acid, you've got all the standard labels for workplace safety. You're going to get a MSDS, Material Safety Data Sheet. Gosh, I'm glad I was able to spit that out. Okay, that has the handleability, the flammability, where you store it, should you keep it dry, and who to contact if you have an accident and so on like that. So all these chemistries are going to come with that. Any of these can kill you, okay? That can put your eyes out. Those can kill you, okay? I'm going to say the same thing about Roundup and dicamba and all the rest of the herbicides and pesticides we deal with, okay? So we've got to be careful. We've got to wash our hands between handling these things and going in the house. Worker safety, you know, in terms of appropriate clothing, appropriate gloves, face protection, eye protection, all very important, okay? You know, and ventilation, very, very important, good ventilation.
Are you using peroxacic acid in the one that has the parabolic
I am.
pump?
I am.
And you're using chlorine in the one that's got the diaphragm pump.
And
In what form is the chlorine? It's in liquid form, but what is it?
we were using an off-labeled for
Clorox
research.
bleach?
Okay, now let's talk about bleach, okay? Clorox, well, I shouldn't say brand name. Bleaches are typically sodium hypochlorite, okay? What we want to use, and we got to get it labeled, is calcium hypochlorite, okay? Calcium negates the issues that sodium has in the soil.
What about the corrosiveness? And as long as you're using PVC pipe, you're all right, and your pump has no metal, the diaphragm's sealed off and your parabolic sealed off. So
That's right. And
if anything that was metal, then you'd be having some serious problems.
you could have some serious problems. I wouldn't, by the time, you know, if you've got an aluminum system out there, I wouldn't be too worried about it. By the time it gets through here, the concentration is low enough that it should be compatible. I mean, typically, even what you're drinking at home, if you're on a municipal water supply, is 1 or 2 part per million chlorine. But when you have it in the concentrate, you'd want to use the PVC or, you know, the poly containers. I wouldn't want to use a metal container and so on like that. Great questions. This is super.
Thank you, John.
Does it take being cold to get these kind of questions? This is great. Okay.
Thank you.
All right.